Today, we're going to be talking about distributed cognition for social resilience.
How do we build resilience in this modern, complex world? I mean, in megacities like Singapore, we are facing interconnected systems. For example, the power grid system, the transportation network, and we know that if something happens in one subsystem, it can have huge effects for the other systems. So resilience is not just a luxury, but we need to develop innovative methods to build up resilience for such cities.
Every day, urban resilience is tested by disruptions, such as traffic congestions, natural disasters, and unforeseen emergencies. A key to overcome these challenges lies in real-time, data-driven decision-making that enhance mobility and public safety.
At Future Resilient Systems, we are shaping the future of urban resilience. One important aspect of resilience is also cognitive resilience, especially when we look at decision makers, for example, in control rooms. Decision makers in control rooms who take care of the transportation system of potential accidents are often overloaded with information. That often results in suboptimal decision making, especially in extreme situations. So, for example, when several accidents happen at the same time. And with our research, including physiological sensors such as eye tracking and skin conductance, we hope to make the decision-making more efficient and effective for control room operators. So for example, one person can see the gaze patterns of the other person, and they can also interact with voice, and that will then lead to more effective and efficient decision-making.
Additionally, the use of AI and big data can help better manage traffic congestions.
In our research, we are trying to represent spatial and temporal context like points of interest, land use, and dynamic phenomena such as weather into neural networks.
By using AI-driven model and big data, we can improve prediction of traffic speed and uncover urban traffic mobility pattern.
And we use these AI methods to actually make better predictions for traffic congestion, for traffic speed, for example. That will actually help us to detect potential dangerous situations early and put in countermeasures, so that will make the whole transportation system more adaptive and more resilient.
We see on the one hand a huge potential of autonomous vehicles to make our transport systems more efficient and safer. And on the other hand, we see already that robo-taxis block whole roads and intersections, for example, in case of sensor failures or in case the AI fails and the vehicle cannot operate autonomously anymore. And in those cases, a remote operator intervenes. FRS is conducting a study here with the NTU Robotics Lab. We try to find out what the ideal interface is for a remote driver to be able to understand the driving situation. So one of the questions we're interested in is whether motion feedback can support the remote driver situation awareness and help them make safe and quick decisions in disruption scenarios to, in the end, contribute to the resilience of an autonomous transport system.
Similarly, for sentiment analysis, we can use AI techniques to explore the huge amount of data on the social media. By analyzing the public sentiment on social media, we can better understand people's response to crises. Social media platforms has become a way for people to share opinions and engage in discussions on various issues. I work with MCCY on some public sentiment analysis to get insight into people's perception on various issues. By leveraging AI-driven models such as large language models to analyze social media data, we can detect events early so that we can communicate effectively with people to achieve a more coordinated response to crises. Together, all these innovations are transforming urban resilience. AI-powered decision-making and social media intelligence enable cities to respond quickly and effectively, creating a smarter and safer city. The faster we can predict or detect potential disruptions, the faster we can take mitigation measures. By identifying key features, we can prevent congestions and even accidents.
Our research is actually transferable worldwide. It does not only apply to cities like Singapore, but also to cities like Zurich. We have a different scale there, but we have the same applications and face the same or similar problems. Our main goal is to derive from our research policy recommendations, so to find out what are potential causes for the problems and how can we find solutions. I think it's extremely important that academics work together and collaborate with policymakers to utilize all these big avalanches of data in combination with evidence-based reasoning and in combination with all the novel technologies such as artificial intelligence and machine learning in order to make our societies more resilient.